Good day, professors. We'll be presenting IoT Pet Tracker as Team 13. Our team members are Aaron T, Cliff Ng, Li Qi, Tan Yujie, and Zowana. I'm Li Qi, and our presentation will cover the introduction, project overview, IoT setup and demo, and conclusion. First, the introduction. Traditional GPS-based pet trackers have limitations hindering optimal functionality. As such, we introduced a novel pet tracking solution leveraging cutting-edge IoT technologies, Bluetooth Low Energy (BLE), and long-range LoRa. Our solution addresses these gaps with innovative hardware devices and a user-friendly web application. Our aim is to empower owners to easily locate their beloved companions anytime, anywhere. Its uses will be the provision of access to the live location of pets in both indoor and outdoor environments, as well as a map interface for pet owners to visualize the location of their pets. The benefits, especially in contrast with existing solutions, will be the accurate real-time location for both indoor environments and outdoor environments, the energy and cost effectiveness due to the nature of BLE and LoRa technologies, as well as being easy to charge, and a user-friendly interface designed to register multiple pets and provide directions for faster location of pets. I'll now pass the time to Zor, who will cover the project overview.
Hi, I'm Zor. I'll be sharing about hardware components and technologies we use for this project. Starting off with hardware, we use LilyGo for communication between devices. We also use MQTT, LoRa, and BLE. We also have a website with Django running as web server, and our choice of database is MySQL to store the coordinates. I'll be now talking about the system architecture. Our tracking system is for both indoors and outdoors use. Starting with outdoors, there are 3 LoRa beacons used as triangulations to get coordinates of the beacon attached to the pet. The data from these beacons are transmitted using MQTT to MQTT broker. For indoors, one BLE beacon is attached to the pet, and another BLE beacon is to receive RSSI values from the pet's beacon, and it also uses MQTT to transmit data to MQTT broker, which link to the web server running on localhost. Coordinates are stored in MySQL, and user can actually visit the website to view the location of the pet on the map. Now Cliff will talk more about the setup.
Thank you, Zor. Next, I'll be presenting on the IoT setup. Firstly, for the outdoor layout, our beacons were placed at about a 10 to 20 meter radius away from the pet collar to test the effectiveness of its transmission. This was done over at an open space at level 1 of SIT NYP. Next is the indoor layout. This was done inside of a lecture theatre to test the effectiveness of BLE. This was conducted of a distance up to 8 meters away from the pet collar. Next, I'll be passing my time on to Aaron.
I'm Aaron, and I'll be covering more in-depth into the hardware implementation. Afterwards, Yujie will cover the IoT application. The pet tracker is implemented as a dual-mode communication system using LoRa and BLE on the LilyGo T13 hardware. We use a round-robin mechanism to broadcast LoRa and BLE signals containing information of the tracker. For indoors tracking, a single BLE beacon is used. The BLE beacon is placed at a known coordinate for ease of tracking. Upon successful connection with the pet tracker in range, the tracker device will send a BLE packet containing its MAC address as its unique identifier, the broadcast sequence number, and its RSSI value. Then, the beacon will relay and publish this information to an MQTT broker via Wi-Fi. For outdoor tracking, 3 LoRa beacons are used. The LoRa beacons are also placed at known coordinates for ease of tracking and for trilateration of the pet tracker position. The pet tracker device broadcasts a LoRa packet containing its MAC address as its unique identifier and the broadcast sequence number. When the pet tracker is in range of the LoRa beacons, the beacons will append the RSSI value with the received LoRa packet. Then, the beacon will relay and publish this information to an MQTT broker via Wi-Fi. Trilateration is a geometric technique used to determine the position of a point by measuring distances to it from known reference points. Instead of distance, we'll be using RSSI values, which indicate the signal strength of a radio transmission. In our implementation, we leverage RSSI values obtained from multiple known points, the LoRa beacons, to estimate the position of the target device. By comparing the RSSI values from known points, we can calculate the distances and triangulate the position of the target. As such, we require only signal strength measurements for pet tracking, eliminating the need for additional hardware such as GPS receivers.
Thank you, Aaron. I'll now be presenting the MQTT and the web server portions of this project. As explained by Aaron earlier, the information published by the LoRa and BLE beacons will be sent to a topic known as T3S3. So the web server will have an MQTT client that is configured to be subscribing to the T3S3 topic to retrieve all the related information from the beacons. So to uniquely classify each message that the beacon is sending, every message will contain the IoT technology used, the beacon's own unique ID, the tracker's ID, which is broadcasted via the LoRa or BLE message, and their respective RSSI values. As shown in the figure on the left, the messages being published by the LoRa beacons contain the IoT communication type, beacon ID, the tracker's ID, the broadcast number, and the RSSI, as mentioned earlier in the previous slide. So the broadcast number is actually used on the web server side, which acts as a way to synchronize the information containing the RSSI values that has been transmitted from the tracker to the beacons. As such, as shown in the figure on the right, the web server will subscribe to the MQTT topic T3S3, and based on the IoT communication protocol, it will determine the exact coordinates of the pet tracker and update the coordinates on the database. As seen in the figure, where LoRa messages was received, trilateration was performed based on the RSSI value from the 3 LoRa beacons to retrieve the coordinates of the tracker. As explained earlier, the web application subscribes to the MQTT broker and retrieves the RSSI values. After making use of the RSSI values to compute the coordinates of the tracker, users can view the location of the tracker via an interactive map on our web application. Additionally, users can also create user accounts to register new trackers to their user account. This is a brief entity relationship diagram that illustrates the information that will be stored in our database. Where the tracker is tied to a user account upon the user registering the tracker via its UUID on a web application. Additionally, each time a new coordinate is computed, the latitude and longitude of the tracker will be updated in the latitude and longitude attributes as seen in the figure on the right. As such, in our web application, users can log into an account to view the registered trackers. They are able to view the real-time location of each tracker via an interactive map where the address and the road name is displayed to the user. Additionally, the last updated time of the tracker is also indicated to the user to let the user know when that tracker was found at that precise location. On top of that, users can get directions to the tracker that they have selected via an A-star algorithm, and specific directions via the road names and distances are also provided to the user. Next, we will be presenting a demonstration on how our system works.
Thank you, Ite. Next, we'll be talking about the conclusion and results. Firstly is the tracking results of BLE. As shown in the demonstration, we are able to send the signal over to the front end and present the location, which as you can see is within the SIT building itself. Secondly is LoRa, who is also able to successfully present its location over at the approximate location at the SIT building using the LoRa devices and trilateration. To elaborate further on our LoRa tracking results, here is a GIF of our live update of the LoRa tracking with Yite holding the endpoint stick and walking towards each of the 3 locations of the beacons. As he is walking towards each of them, the location on his laptop is being updated to show the location based on the trilateration of the 3 beacons. Based on the results shown, some future works that can be explored is the usage of LoRaWAN. By updating the prototype to use this technology instead, it will help greatly improve the scalability of it over a much larger area. Next would be the improvement of existing features, such as the accuracy of the location tracking that is presented on the front end. As currently, there may be margins of error that are shown based on the pin location that is presented. Lastly would be to improve on the hardware, as the T3S3 may face certain inaccuracies or delayed delivery time in the signal transmission that may cause errors within the product itself. Thank you for coming to our presentation.